Good day, grade 11. In this lesson, we're carrying on with intermolecular forces, and we're just going to be speaking about two specific things. And the first thing we're going to be looking at is how the intermolecular forces affect the physical properties of different substances. Now, we've kind of mentioned it before, but now we're going to be very specific. Okay, so first of all, the intermolecular forces determine the different physical properties of solids and liquids. Okay, remember we spoke about hydrogen bonding and how hydrogen bonding causes things to have higher melting points and higher boiling points because they're stronger. Well, that's what we're talking about, okay? And substances with large molecules have stronger intermolecular forces than those with smaller molecules. Substances with larger molecules have stronger intermolecular forces, so the longer the chain, the bigger the molecule, the stronger the intermolecular force. Now let's look at the different properties and discuss what they are of the different physical properties of liquids and solids, and then talk about how the intermolecular force is affected. Okay, so viscosity is a measure of the rate of flow of a liquid. Okay, viscosity is a measure of rate of flow of liquid. In other words, the higher the viscosity, the slower the rate of flow. So honey is going to have a much higher viscosity than water. Okay, honey is going to have much higher viscosity than water. So the larger the molecule, the stronger the intermolecular forces, therefore the greater the viscosity. Okay, so larger molecules will have stronger intermolecular forces, and then they have therefore greater viscosity. Okay, so therefore we can immediately tell that honey has got much stronger intermolecular forces than water. So that's viscosity. And guys, you need to know the definitions of all these things that we mentioned. So you need to know that the definition of viscosity is a measure of the rate of flow of a liquid. Right, next one. Density. Density is a measure of the mass per unit volume. So if you look at this picture, you can see that for any substance, gas, liquid, and solid, that the solid is the most dense because it has the greatest number of particles per unit volume. Then there's liquid and there's solid. And again, the bigger the molecules, the stronger the intermolecular forces, the closer the molecules are going to be allowed to move close to each other, and therefore the greater the density. So the greater density of a substance means it's got a greater intermolecular force. Okay, next, boiling points and melting points. So the reason I'm showing you this is because of something we've already spoken about. If you look over here, you can see that here we've got water, and you can see water has got a very high boiling point. It's got 100 degrees. Then you've got hydrogen sulfide, which is minus 50, and then hydrogen selenium and hydrogen tellurium. Okay, and you can see that it slowly goes up. But what's special about water? What's special about water is water has got hydrogen bonding. Hydrogen bonding. Okay, and remember what we said, hydrogen bonding was the strongest of the intermolecular forces. So that is why it's got such a high boiling point, okay? And then if you look at this, you can see that this boiling point is going up slowly because these do not have hydrogen bonding, but this molecule is bigger than this molecule, which in turn is bigger than this molecule. So therefore this one's intermolecular forces are going to be stronger than the hydrogen selenium, which again is stronger than hydrogen sulfide. So that's why that's slowly going up. Right, so boiling points and melting points are basically things that you need to know about, and boiling point is obviously the temperature at which liquid turns to gas, and melting point the temperature at which solid turns to liquid. Okay, and those are two of the physical properties that are affected by your intermolecular forces. Thermal expansion. Oh, it's how well does something expand. This is expansion of liquid on heating. Substances with smaller molecules will have weaker intermolecular forces, and therefore they will expand more easily. That makes sense, hey, because if you've got a weak intermolecular force between the two, then obviously you'll be able to allow the molecules to move further apart. And a typical thing that we use nowadays, the older thermometers, this is a thermometer, and the older thermometers used to have a silver liquid in it, Okay, in fact they're still used quite a lot today, but they're not sold anymore, and that was mercury. And the reason they're not sold anymore is that although mercury is liquid at room temperature, it's unfortunately very poisonous. So the last thing you want is to put mercury thermometer in your mouth and then by mistake you bite down on the thermometer, say you're very sick and you have a fit, and then you have mercury in your mouth. Where this is alcohol, okay, and it's not, don't worry, it's not alcohol you can get drunk on, so don't even think about it, okay, and it's red because they've colored it so you can see it. So this is alcohol, and although alcohol has got fairly strong intermolecular forces, they're not that strong. So what happens is as it heats up, this will expand up the thermometer, okay, up the thermometer, or if it cools down, it will go smaller, it will contract, okay, and this is because of your weaker intermolecular forces, okay. So that's one use that we use of the ability of liquids to expand or contract when heated. Next is thermal conductivity. This is a measure of how much the material conducts heat. Okay, and this works both with thermal conductivity as well as electrical conductivity. If you have a metallic lattice, you can see that these have got your protons and then you've got your sea of free electrons, okay? And you can see that these particles are very, very close together. So obviously they are going to very easily conduct electricity or heat. Whereas if you've got something that is structured, okay, like this, it's going to be very difficult for this particle to cause that particle to feel the heat, okay? This will have to actually get very hot, break where it's sitting, okay, and then it's going to have to go and bump into the chloride ion or vice versa into this chloride ion. So similarly with being electrical, it's going to not very easily conduct electricity, so it cannot very easily conduct heat, okay. Surface tension. Now surface tension is pretty cool. So this is the energy required to increase the surface area, okay. Funny definition for it, this is the energy required to increase the surface area. In other words, it's the energy required to break the surface, okay. So you need to know that there are two types of forces. There are forces of cohesion, which are the forces between the molecules of the same kind, which will be in the liquid, and the forces of adhesion, which are the forces between the liquid molecules and the side of the container. And both forces of cohesion and adhesion are the intermolecular forces. So let's look at a little picture here. So I don't know if you can see very well, but if you look at this side here on the left, there's water, okay, and you'll notice that it does that, okay, and then it carries on there. Whereas mercury, when I put this in liquid mercury, yeah, it does this. Oh, terrible drawing. Okay, and that. Right. So what is it showing? Yeah, it's showing this is your meniscus. It's called a meniscus, and you need to know the name. So let me write it down. Meniscus. And whenever they talk about reading and they talk about the error of parallax, they're talking about the fact that you need to read. Let's say if this was in a measuring tube, you have to read, if it's water, you have to read from the bottom of the meniscus, and if it's mercury, read from the top of the meniscus, the point right at the top. And this meniscus forms simply because of these forces, the forces of cohesion and the forces of adhesion. And the reason that these two shapes are different is because the forces of cohesion, okay, which are the forces between the molecules in your water, are weaker than the forces of adhesion. So the forces of adhesion are pulling the water up the side, okay, so they're pulling it up the side of the container because of these very strong forces of adhesion. Whereas in mercury is a metal that is liquid at room temperature, if you didn't know that already. And what happens here, the forces of cohesion are actually stronger, they are bigger than the forces of adhesion. So that means that they actually stick, they're more likely for the molecules in the mercury to be sticking closer to each other than to be closer to the water. So they actually pull away from the glass because the forces of cohesion are stronger than forces of adhesion. Whereas over here, the forces of adhesion are stronger than the forces of cohesion, which cause this general curve. And you guys, obviously the thinner this is, the thinner the container is, like this will generally be a very thin straw, this very sharper the curve will be. Whereas if this was in a beaker, and you will notice this, you can go look at a glass of water, make sure the glass is clean, and then go look, and you will see a very gentle shape like that if you've got water in it. Okay, but there's a general shape like that, and the reason is because of the force of adhesion between the molecules of the water and the molecules of the glass, which are stronger than the forces of cohesion. Okay, and that grade 11s are all the, well, not all, but the most important physical properties of liquids and solids and how intermolecular forces affect this. Have a great day.